Did you live right here?
I did, like, right before you started going to USB to the class, I had some class.
That's great.
My mom went to the next block.
Highway, which highway? Yeah.
They didn't clear it all. They didn't put salt on it. All really stupid. So 364 was like standstill. Yeah.
Yeah. Well. All right, here we go. Are we ready? So we've always been told that we can't simplify the square root of a negative value, but we can. From today on, we can, okay? We define the square root of -1 to be I. The square root of -1 is I. Okay? So there's a pattern that we work with when we work with I. When we look at our answers and we're dealing with the square roots of negative values, our answers can't have an exponent on I be any higher than to the first power. Okay? So let's look at what happens. If I equals the square root, now look at that negative sign is under the root. Okay? It's not out in front of the root, it's under the root. Then if we were to expand out I squared, wouldn't we say that it's I times I? Right? Would you agree? So each I represents the square root of -1. So square roots of -1 times square roots of -1. Well, the square root of a value times itself is always the value under the root. Would you agree? So what is square roots of -1 times square roots of -1? -1. Okay, so I squared is defined to be, or simplified down to, -1. I cubed. Well, that's I squared times I. But what did we just define I squared to be? So this is really -1 times I, which is really just -I. Are we good? All right, I to the 4th. I squared times I squared. And each time you have I squared, you can simplify it down to what? -1. So what's -1 times -1? Right. So when you have I to the 4th power, you really can say that that has a value of 1. Now, square roots of negative values are actually used in real life. They have to do with electrical engineering, and they have to do with how currents flow. So they tell us some information. Okay, so there is some validity. It's not just something that we've made up. All right, I to the 5th. Would we agree that that's I to the 4th times I to the 1st? But what's I to the 4th? So that means it's back down to I. So I to the 5th is the same thing as I to the 1st. Yeah. Okay, Mackenzie? Now? Okay. Maggie, I think your mom's here to pick you up. Oh. Uh-huh.
What's that? If I equals -1,
No, I doesn't equal -1. I equals the square root of -1. There's a difference. Okay, you can't take the square root of -1 on your calculator. It gives you an error message. So we label it with the value I, meaning imaginary number. Okay? It's an imaginary number that we use in electrical engineering. Okay? All right, yes? I'll show you. I'll show you. Let's just get what I means right now. Okay? Let's look for our pattern. I to the 23rd. Well, every time, let's do something simpler. What is I to the 8th going to be? I to the 4th, no, gotta get your rules right, times I to the... So what's your rule? With your like bases, what do you do with your exponents? Add them. So I to the 8th is I to the 4th times I to the... So what's every I to the 4th? So I to the 8th is 1 times 1, which is 1. So every time we have a multiple of 4 as our exponent, that value for I becomes what value? 1, okay? So what is the highest exponent that we could take, I2, without going over 23? So 4, 16, 20. Isn't I to the 23rd I to the 20 times I to the 3rd? You following this? And what is I to the 20 going to be? Because it's a multiple of I to the 4th. 1. So this is really 1 times I to the 3rd. But what's I to the 3rd? So that's really 1 times negative I, which is really just negative I, exactly. So that's why every form of I to some power can be simplified down to 1 or negative I or negative 1. Those are my choices. And then I start repeating myself. Does that make sense? I'm sorry. Okay. So let's see how we apply it. All right. So we know how to solve this equation. We would take the 11 to the right side, and we'd say that 2x squared is equal to negative 48. Dividing, we'd say x squared is equal to negative 24. And taking the square root, in the past you would say can't be done. Correct? But what I'm saying is we can do it. We can take the square root of both sides, and we're going to get x is equal to plus and minus the square root of negative 24. We never write an answer with a value of a negative sign under the square root. So I'm going to say that's plus and minus the square root of 24 times the square root of what? Negative 1. But what did we just define negative, or the square root of negative 1 to be? I. Plus and minus square roots of 24I. I is outside the square root. Now, the square root of 24 we can further simplify down, can't we? It is 4 times 6, correct? So that really means it's plus and minus 2. We usually stick the I out in front of the square root and then put the square root down. Does that make sense? So the only thing that's different now is that we're dealing with a negative value under the square root, and we're going to define that to be I. All the other work that we've done is the same. Okay? Yeah, you can keep it out to the side, but usually the book will write it out in front.
So it's like plus or minus
Doesn't matter. You can do the plus and minus I square root of 24. You just don't want to do this, I plus and minus square root of 24. That I has to be multiplied by the root, so this part's not right. Okay? All right, take the square root of both sides here. And I'm going to get x is equal to plus and minus the square root of negative 13. What's that negative value underneath going to really be written as? I. So I'm just going to jump right down to I root 13. I mean, you can show me square roots of 13 times square roots of negative 1, but if you can recognize that that negative sign under the root is just your I, then you can jump right to that step. Does that make sense? Okay? All right, next one. You try that one. You do the next one. You do need to write plus and minus the square root of negative 6 because you took the square root of an equation. Right? And in an equation, when you take the square root, you always get a positive and a negative. Are we good? Got it? Okay, next one. So, you can do all kinds of things with these i's, and we want to treat them as if they were a variable in terms of if we adding and subtracting or multiplying, okay? But there is a correct way to write an answer when you have an imaginary number. And the standard form is this a plus bi, where a is your real number, like 2, or 1/3, or -5. And the bi is your imaginary part. It's the one that's got the I, like 3i. And the whole answer is called a complex number because it's got the real and it has the imaginary part. So the whole answer is complex. So 3i plus 2 is not in standard form. How should I write it? 2 plus 3i. Exactly. Okay? I will take off. If you get the order flipped and you put your imaginary part first, I will take off because you have to get it in the right format. Okay, so we're going to look at these i's, which we know to be the square root of -1, right? But we're going to just look at this in these types of problems as if they were just a normal variable. And they're going to follow the same rules. So if I'm separating two parentheses by an addition or a subtraction sign, I know that I have to lose my parentheses so that I can combine my like terms. And in this case, I can just remove the parentheses without worrying about any sign changes. So I'm left with 8 minus I plus 5 plus 4i. And we combine our like terms. We're going to do the real part first. What's 8 plus 5? All right, then we do the imaginary part. What's -I plus 4i? And I'm done. Mackenzie? Because I'm not multiplying these two parentheses, I'm adding them. And this addition sign, if I pull it through, it doesn't change any of my signs. And so they aren't really needed other than to tell me that there's a difference between this piece of information and this one. Whereas in this next one, if I want to lose the parentheses so I can combine like terms, I got to pull that negative sign through to both of those terms. And so what I would really say is 3 plus 7i minus 8 plus 2i. And the most common mistake is to forget to pull that negative sign to the 2i also, and not just put it with the first term.
But you don't put it with the second, that first.
No, because it's minus that value. I don't have the negative sign in front of my first parentheses. So doing my real part, I get -5, and my imaginary part, I get plus 9i, and I'm done. Are we good? All right, you do the last one. So I got -10 minus 8i. Would you agree? I didn't do a careless mistake? Okay. Anybody got a question? Mackenzie? Okay, right. So don't forget to pull it through both. Okay, so now we're going to do some multiplication through distribution or FOILing. Okay, follow the same rules for exponents. We take I times 9 and get 9i. We take I times I and get I squared. But remember at the beginning of this I said our answer cannot have an exponent higher than 1 on your i's. So what was I squared? I squared was -1. So this is really saying 9i plus, instead of writing I squared, we're going to write -1. And we got to make sure that we get our order right. What's the correct order to write this in? Exactly. And we're done. Mm-hmm. No, so it goes back to this pattern here. I is defined to be the square root of negative 1. I squared is defined to be always negative 1. I cubed is negative I, and I to the fourth is 1. And these are what you need to memorize. Exactly. Because remember, we can break it down. Then we look for powers of 4 that we can pull out because we know there'll be 1. Okay? Did I answer your question, Mackenzie? All right, so this one we're going to distribute or FOIL. We'll say that's 15 minus 3i plus 5i minus I squared. But what's I squared? So this is 15 minus 3i plus 5i minus negative 1. Your error that you make will be thinking, well, I already have a negative, so I'm just going to write 1. It's the opposite of negative 1. I squared is negative 1. It doesn't matter if the sign in front of it is positive or negative. Okay? Combining our like terms, this gives me 2i. I've got 15 plus 2i plus 1, which is 16 plus 2i. Are we good? Okay. So, we can't have i's in the denominator, like we can't have square roots in the denominator. So what did we do when we were adding or subtracting square roots? What did we multiply top and bottom by? The conjugates. We're going to use that same thought when we're doing this one because we're adding or subtracting an I. So what would be the conjugate that I'd multiply numerator and denominator by? 1 minus I over 1 minus I. And then we just go through the same process that we did as if we were working with our square roots. We'd say that's 5 minus 5I. And then we're foiling in the denominator. 1 minus I plus I minus I squared. Okay, and as with any conjugate, if you've done it right, the middle terms drop out, correct? So, and what did we say I squared was? So what I really have down here is 1 minus negative 1. Wouldn't you agree? Which is? So this is 5 minus 5i over 2. Now, if you remember back, I said the standard form is a plus bi. How many terms do we have here? 2, right? How many terms have I written this as? So a term is a number separated by another number with no common divisions. How many terms do I have? I have 3 numbers. I have 1 term. So how do I separate this so that I have the real part and the imaginary part? Elizabeth? Yeah, just divide, just separate your denominators and put them over both of those numerators. Okay? This is standard form now. Will I take off? Absolutely. If you don't separate it. Okay? Try the next one yourself. What do we do? Did we get it right? Adace? I'm glad you asked that. Rules for division. Can you take it out of every single term? Then you can't. So you're right. The 4i squares cannot cancel. I can't take a 4 out of all 4 terms in my denominator and all 4 terms in my numerator. So I cannot reduce it. Okay? Yes?
So you don't want any I squared at all?
The highest exponent I can have is an I to the first. Okay? Did we get it right? Anybody got a question? Okay. Last page. Okay. What? We better learn that quick. Got lots of graphing going on this year, Charlie. I just remember Y has a tail. That means it goes down. That's how I remember it. And I know that in my ordered pair, I do it alphabetically. First the X, then the Y. No? Because Rise Over Run tells you to do the Y first and then the X. So if that's what you're doing, that's why you're getting them backwards.
I should not be using Rise Over Run.
You want to think alphabetically. X, Y. Right, left. Do you say left, right, or right, left? Yeah. Right or up and down. Okay, here we go. So we're going to plot this on an imaginary axis. And what that means is X becomes our real axis and Y becomes our imaginary now. Okay? So you look at 2 plus 3i as a point, 2, comma, 3i. With this being your left, right, and this being your up, down, specifically for Charlie. Okay? So if I'm trying to plot 2 plus 3i starting at the origin, that means I go over 2 units and then 1, 2, 3. There is 2 plus 3i. Now the book also asks you to find the distance. Well, that's easy. You're just creating yourself a little right triangle. You can use the Pythagorean theorem, but the Pythagorean theorem is a form of the distance formula. What is your x distance? 2. What is your y distance? 3, not 3i. I tells me going vertically. I is our direction, okay? Squared, that's our distance. So this is the square root of 4 plus 9, which is the square root of 13. This is the square, this is my distance, and this has a length of the square root of 13. It's just your hypotenuse on a right triangle. Okay? How do I plot negative 4 minus 2i? From the origin, which way do I go? Left, how many units? 1, 2, 3, 4. Then I go down 2. There is negative 4 minus 2i. What's that distance? How do I figure it out? The square root of my x value. What's my x value? Negative 4 squared. And my y value? Negative 2 squared. Notice, girls, I'm putting my negative 4 in parentheses and squaring it. This value, when I square it, is positive. Square root of 16 plus 4, square root of 20, which is 2 root 5. Does that make sense? So that means it's to the origin. Okay. If I go negative 6i, where do I plot it? On the end, 1, 2, 3, 4, 5, 6. And for argument's sakes, what do you think that distance is? So distance is a positive. So how many units have you gone? You've gone 6, right. You can take the square root of negative 6 squared plus 0 squared. Square root of 36 gives me 6, or you can just count down. Okay? Where do I plot negative 3 plus 4i? From the origin, I go Left 3, 1, 2, 3, and 1, 2, 3, 4. There is negative 3 plus 4i. What's my distance? So 9 plus, which is 5. Square root of 25, which is 5, right? Making some sense? Pretty straightforward? All righty.